Okay, here's some examples of graphing polynomials in expanded form. Now, we've already graphed polynomials in factored form. That's not too difficult. But when they're expanded like this, we need to get them into factored form so we can graph them. And if we look at this, first thing we always try is a four-term grouping to see if we can factor something out of these two terms and these two terms. Well, I can get an x squared out of these two terms, but I can't factor anything out of 3 and 10. So I can't do kind of a grouping factoring method. So what we'll try to do is we'll try to see if we can find some rational roots and maybe reduce this equation from a cubic to a quadratic by dividing out a rational root. And we have the rational zero, and we have the rational zero theorem. Remember, zero and roots are the same thing. 6 and 1/2 a dozen of the other, same thing. So what we can say here is this rational zero theorem, remember our rational zero theorem, says that if we do have a rational root of this polynomial, it will be of the form c over b, of a rational number. And remember, 2 is a rational number because 2 over 1 is a fraction. It simplifies to be 2, so 3 is also a rational number. In this case, the b would be 1. So it's going to be a of this form c over b, where the c is a factor of 10. So some factor of 10 will comprise the numerator of our rational root, and some factor of 1, that's the leading coefficient, will determine the denominator of our rational root. So we always just look at the constant term and the leading coefficient. So in order to do this, we just try all the factors of 10. That would be plus or minus 1, plus or minus 2 goes into 10, plus or minus 5, and plus or minus 10. These are the factors of 10. And on the bottom, we just have all the factors of 1, which is just plus or minus 1. All right, so our factors are just going to be these four: plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. So those are the possible rational roots we have. So the way we find out is we just use our remainder theorem. We just divide by each of these until we get a remainder of 0. Then we know that that's going to be a 0. So let's start with 1. We'll do synthetic division. That's going to be a lot easier than long division. And we'll divide that in my coefficients are 1, negative 6, negative 6, plus 3, and 10. And then we draw our line down here and see what we got. So we bring down our 1. 1 times 1 is 1. Negative 6 plus 1 is negative 5. Negative 5, that's going to be negative 2. And 1 times negative 2 is negative 2. And that's going to give me 8. So I got a remainder of 8, so 1 is not a 0 because I have a remainder. Okay? Let's try another one. Let's try negative 1. That would be the next one. And they get the same numbers: 1, negative 6, plus 3, plus 10. And we've got to bring down our 1, so negative 1. That's going to be negative 7. Negative, multiply, remember we bring down the 1, then we multiply, add, multiply, that's going to be positive 7, add, multiply, that's going to be negative 10 plus 10, aha, we have a 0 there. So that means that negative 1 is a 0. And remember, if negative 1 is a 0, what does that mean? Is a factor. That means that x minus negative 1 or x plus 1 is a factor. So I can look over here and I know that my other factor, so I've got x plus 1 is a factor. And the other factor is my reduced equation. Now remember, since this was a cubic, I go 1 less into the third power, and this is going to be x to the second. I mean, 1 less of the third is the second power. 1 less than 3 is 2. So I'm going to go x squared minus 7x plus 10. So I get these numbers from here. Okay, 1 here, negative 7 there, and 10 there. All right, and that's going to be x squared because that's going to be 1 less than x cubed. And if you multiply these, x times x squared is x cubed. That's what we got. Because remember, they're factors, we multiply them. If we multiply this binomial times this trinomial, we're going to get this 4-term quadratic. But we can factor this because we have a nice simple trinomial. So that's what we're going to do. And I know that it's going to be x times x. This tells me that these signs are going to be the same. This tells me what they're going to be. They're both going to be negative. So if I have to multiply to give 10, and they're same, the sum is 7, so we would say 2 and 5. And then we can also have this. So now we have the 3 factors. All right? So that's not too bad. And if we multiply these 3, of course we would get this. And if we multiply, because if we multiply these 2, we get that trinomial because that's how we factored it. So what are my zeros? My zeros are going to be x equals opposite, -1, and that's what we had up here, -1. You can see that. -1 was a 0. And then 2 and 5. And any of these numbers, if I put any of these numbers in here, -1 plus 1 is 0, 0 times anything is 0. If I put 2 in here, 2 minus 2 is 0, 0 times anything is 0. If I put 5 in here, 5 minus 5 is 0, 0 times anything is 0. And if I put any of these numbers in the expanded form, I would also get 0. That's why I call them zeros. Okay? So those are my zeros. Now we also can find the y-intercept, and the y-intercept is when x is 0. And that's going to be the point 0 something, because x is 0. So what's y when x is 0? Well, that's real easy when it's in expanded form, because this is 0, that's 0, that's 0, so the only things left is y equals 10. So there's your intercept. So those are the 4 points we want to put on here. Now, we know it's going to go through there. We don't know what's going to happen around the intercept, but we know it's going to go there. Now my zeros were -1, so I put those on my graph. 2, there's 1, 2, 3, 4, 5. So something like this, and we'll mark those zeros in. -1, 2, and 5. And my intercept was 10. Now where do we start? Do we start up here or do we start down here? So let's look at the in behavior. And I can do it 2 ways. I can just look at this and I can say y equals x. Y equals x cubed. Or I could just add up these and I have 1, 2, 3, y equals x cubed. So that's going to be my in behavior. And that's positive odd, so that's my easiest positive odd function is y equals x. And that's just a diagonal line with a positive slope of 1. So that's just going to look like this. So that's our model. Remember, we only have 4 ways as these can look. So there's my in behavior right there, lower left to upper right. So that's what we've got. Now we're ready to graph it. Well, one more thing we want to check on what happens at these zeros. Does it cross or bounce? And these are all powers of 1. Actually, we can actually say y equals this. This is my polynomial. And these are all powers of 1. So in each case, since the powers are odd, it crosses, crosses, crosses. So there you go. And sometimes I've done the end behavior first, but I kind of ran out of room up here, so just have to do it before we graph. So there's your end behavior. Okay, got it in factored form. Find my zeros, and I'm ready to graph. And I'll start with a pencil just so I can erase it if I don't get it as nice as I'd like. So it's going to start lower left. It's going to come up here. It's going to be kind of steep because it's going to go up to 10. Let's see, that's why I use pencil. Okay. Turn around at 10. And it may go past that, it may go up above it. It could go up above it, it's just going to go through there. So I'll just have it go up above it a little bit and come back down because the 2's over on this side. So I'll assume maybe in the middle between -1 and 2 is going to reach its crest, so maybe to come up like that. All we really know is that it goes through here. We don't know if it's going to go up like that and come down or like that. So we're just estimating that it's going to come down here and curve back around and go through the 5. And there we go, something like this. And there's your graph. Kind of estimating this. And we can assume maybe the crest of this thing, the top of this thing, will be halfway between -1 and 2, which should be a half. We can kind of estimate that just by looking at what's going on. But we don't know for sure. There are other ways to do this, and when you take calculus, you can find out exactly where that point will be and exactly where that point will be. Okay? So there you go. Hope that all makes sense. Now you can always pause this, go back and check it and make sure you understand everything we did and why we did it.